Welcome to our lesson on multiplying and dividing using numbers in standard form. So below the do now task is a follow-up from our previous lesson on adding and subtracting numbers in standard form. Please pause the video, have a go at the do now task, and then I will give you the answers. Welcome back. So in the first one, 1 times 10 to the 3 plus 3 times 10 to the 3, as you'll remember from our lesson yesterday, we can simply choose to write each number in standard form with the same powers of 10, in this case they already are, and the 1 and the 3 makes 4. Or you may have chosen to write your numbers as normal numbers and then convert back. B, 1.3 times 10 to the 4. Looking at the place value, you can see that the 1 is in a different column from the 3, which actually makes the question easier. C was subtraction. D, we had more numbers to deal with, and obviously we were dealing with decimals. And E, 2.08 times 10 to the negative 8. So, what we're going to look at today then is the hook. We use, as we know, standard form when we're dealing with big numbers in calculations. If you think about how we might be able to find out how long it takes light to reach us from the sun. The speed of light is often referred to as c. Think about the famous equation that you may have heard of, E equals mc squared. The c in that is actually the speed of light. E is energy and m is mass. So in this case, what we're interested in is this value c, which is approximately 3 times 10 to the 8 meters per second. Equally, we refer to the distance to the sun as being 1 astronomical unit, and that's a way of us measuring other things in the solar system. So the distance from the Earth to the sun, 1 astronomical unit, is approximately 1.4 times 10 to the 11 meters. So, how long will it take a light ray to reach Earth from the sun? Right then, our success criteria. We need to know how to use simple, standard form numbers in multiplication and division. We need to understand the laws of indices and how we use multiplication and division with standard form numbers. And at the more challenging end, we need to be able to use standard form to perform calculations with numbers that are too big to be practically performed with ordinary numbers. And there are many times when people are dealing with scheduling problems, things like a sat-nav in a car, the number of possible combinations of journey it could come up with are actually very, very large, and obviously it has to find its way through those. So, quick thing to get started with then, cold call question, 30 seconds, think about what happens when we multiply the value 10 to the a multiplied by 10 to the power b. If you need to pause the video and have a think, please do so. So obviously we should remember that when we have the same base, in this case 10 to the a times 10 to the b is just the same as 10 to the a plus b. Now if you're not too sure about that, you could replace a with 1, so 10 to the power 1 is 10, b with 2, so 10 to the power 2 would be 100, and 10 times 100 is 1000, which is 10 to the power 3. Similarly with division, we have a similar rule, but when we're dividing, we subtract. And again, if you use values for a and b, like 1 and 2, or any other number, you can check that out. So, if we look on the left-hand side now, the teach side, what we're going to do is multiply two numbers together that are written in standard form. So we're going to multiply 2 times 10 to the 3 by 3 times 10 to the 2. So the first thing I'm going to do is their multiplications. So we can change the order round because they're all multiplications. So I can actually do 2 times 3 multiplied by 10 to the 3 and 10 to the 2, which means I can do 2 times 3 is 6. So what we've taken are these two values here, and then we can use our rules of indices here to get 10 to the power 5. So in actual fact, we get the solution 6 times 10 to the power 5. Apologies. At this point, if you have a look on the right hand side and pause the video when you're ready to see the question, you'll have already seen the hint, which is to rewrite it in the same way as we did on the left hand side. So please pause the video and have a go at the question on the right. Welcome back. As you've already seen, the first thing to do is to write everything where we have the 6 and the 1 together on the left and the powers of 10 on the right hand side. We can then do 6 times 1 is 6, and 10 to the power 6 times 10 to the power negative 2 gives us 10 to the power 4. So we end up with 6 times 10 to the power 4. So what I would now like you to do is, in a moment, pause the video and have a go at the 10 questions. I will then reveal the answers after you've completed them. So, hopefully you've managed to complete those 10 questions, and let's have a look at the answers. So in the first one, we've got the 8 times the 2.5, which gives us the 2, and obviously 2.5 times 8 is actually 20. Our 1 and our 3 makes 10 to the power 4, and of course that 20, we can't have 20 to the power 10 to the 4. What we need to do is have 2 times 10 to the power 4. So, next one, 7.5 this time divided by 3 is going to give me 2.5, and then I'm going to subtract the powers. In this case, I'm going to do 8 times 7, and the answer to the 8 times 7, I will also have 10 to the power 4 with it. So there's my 56 times 10 to the power 4 is actually 5.6 times 10 to the power 5. And again, 8 times 9.5, whichever calculation method you would use for that. Remember, of course, you can't have 76. So we have 10 to the power 4 and 10 to the power 5 is 10 to the power 9 with the extra power to make 10 to the 10. Continuing, 7.5 times 10 to the negative 3. 8 times 10 to the negative 1. 6.5 times 10 to the 13. This time, remember, of course, you're subtracting negative 7. 4 times 10 to the 0, so we're going to end up with 12 times 10 to the 4. But of course we can't have 12, so we need 1.2 times 10 to the 5. Last two, 1.65 times 10 to the negative 17, because the 3 times the 5 gives us a number greater than 10. So our negative 18, we can then correct that power to negative 17. And 7 divided by 7 is 1. So we end up with 1 times 10 to the negative 14, as negative 8 subtract 6 is negative 14. Next then, have a look at the calculations, and you need to decide which inequality or equal sign to place in the middle to make the statements correct. So please pause the video and have a go at the 3 questions. Welcome back. So we're going to have a look on the left hand side and the right hand side, and our 8 times 6 is going to give us 48 times 10 to the power 9. Of course we can't have 48 times 10 to the power 9, so we're going to have 4.8 times 10 to the 10. We can then compare that with the number on the right hand side, which gives us 4. 8 divided by 2 is 4, times 10 to the power 9, which obviously is slightly smaller. For B, the inequality goes that way around. And for the one at the bottom, again, the right hand side is the greater. Okay, continuing onwards. So if we have a look at a non-standard example, obviously we have this idea of £1 trillion pounds or $1 trillion that the government may be spending. $1 trillion is just 1,000 billion. But equally, we know there are approximately 40 trillion cells in the human body, and a single cell could contain 100 trillion atoms. So the next question is, how many atoms in the human body? Can you give your answer in standard form? Secondly, if you look at the numbers at the bottom of the page, can you arrange them in size order, beginning with the smallest? So please, just pause the video and have a think, and then we'll look at the solutions. Welcome back. So if $1 trillion is 1,000 billion, I know that a billion is 10 to the power 9, so $1 trillion must be 10 to the power 12. 40 trillion must therefore be 40 times 10 to the 12, but we can't have 40 times 10 to the 12, we want 4 times 10 to the 13. Now each cell consists of 100 trillion atoms, which is 100 times 10 to the 12, which is of course 1 times 10 to the 14. So how many atoms are in the human body? We simply need to do 1 times 4 is 4. 10 to the 14 multiplied by 10 to the 13 is 10 to the power 27. Which, as you can imagine, is an extraordinarily large number and very difficult to write down on a normal sheet of paper with all the zeros. The numbers at the bottom, obviously, hopefully most of you just went straight away and used the ideas of sorting things out into standard form perhaps. So our 0.038 times 10 to the 2 was not in standard form, so we could change the place value and make 3.8. Our 3,800 times 10 to the negative 4, again, not quite in standard form, so we can't just do a comparison, 0.38. 380 is 380, and lastly, 0.38 times 10 to the negative 1, decrease that by 1, so we can now arrange those numbers in size order. The one on the right being the smallest, and then obviously second, third, and finally 380 being the largest. Okay. True or false? This headline appeared in a newspaper. Every day, 7% of Americans eat at giant burger restaurants. So we need to decide whether this headline is true using the following information. There are 8 times 10 to the 3 giant burger restaurants in America. Each restaurant serves approximately 2.5 times 10 to the 3 people per day, and there are approximately 3 times 10 to the 8 Americans. So what I'd like you to do is pause the video and try and explain your reasons and show clearly how you solve the question. Welcome back. So let's have a look. What do we know? We have the number of restaurants as 8 times 10 to the 3, and the number of people they serve per restaurant as 2.5 times 10 to the 3. So if we multiply those two numbers together, we get approximately 2 times 10 to the 7. Now what we need to know is, what is this as a percentage of the population of the United States? And hopefully you'll remember from your percentage lessons, we can find a percentage by writing it as a fraction. So we have our people who ate at the restaurant, 2 times 10 to the 7, divided by the total population of America, 3 times 10 to the 8, which gives me the answer 6.7 times 10 to the negative 2. If we now convert this to a normal number, you can see we would end up with 0.067, which is approximately 6.7%. So almost 7% of Americans, it would appear, eat at a giant burger restaurant. Okay. So back to the question from the beginning of the lesson. Jimmy says that the light from the sun takes 1 hour to get to Earth, and this is how he worked it out. The speed of light is 3 times 10 to the 8 meters per second. The sun is 1 AU, or 1.4 times 10 to the 11 meters away. Jimmy knows that time is distance divided by speed from his science lesson, or of course for his distance, speed and time triangle. So distance, speed and time. So Jimmy decides to divide the distance of the sun by the speed of light. So he's got his 1.4 times 10 to the 11 over his 3.0 times 10 to the 8. He ends up with a value of 0.466 times 10 to the 3. Is he correct? So I'd like you to pause the video, look at his working out and make a decision. Welcome back. So in standard form, that number would have been 4.66 times 10 to the 2. As a normal number, that would be 466. 466 seconds is approximately 8 minutes. So Jimmy is wrong. It only takes 8 minutes for light to leave the sun and reach Earth. The time taken for light to reach the Earth from the edge of the known universe is 14 and 9 zeros. Light travels at a speed of 9.46 times 10 to the 12 kilometers per year. Can we work out the distance in kilometers from the edge of the known universe to Earth and give an answer in standard form? So I'd like you to pause the video and have a go at the question. Welcome back. So we know that distance is speed times time. If we take the two numbers and multiply them, we get 1.3244 times 10 to the 23. Comparing that to our previous numbers, what do we know? That the distance is 1 followed by approximately 23 zeros, which is rather a long thing. Lastly, what I would like to do for the third lesson this week is there is a video at the end of this PowerPoint that I would like you to watch. If you watch the video, it takes about 5 minutes. It will explain how to use a Casio calculator to carry out standard form calculations. Once you have completed the video, I would then like you to revisit yesterday's PowerPoint and today's PowerPoint and see if you can check your answers on your calculator and agree with the values we got during those lessons. So, at that point, thank you very much, ladies and gentlemen, and good luck.